Hello students, I'd like to go over the test 1-2 review. So let's go over the answers to these real quick. Okay, so the first section of the review is about definitions. Okay, so natural numbers. We know that that is nothing but the numbers that we count with, like 1, 2, 3, 4, and so on. Whole numbers, it's the natural numbers and 0, right? Integers, the whole numbers and their opposites. So this brings about all of the negative ones. Okay, now so far, natural, whole, and integers, there are no decimal or fraction parts. Okay, so that's the important thing. So if you see a positive number like a 5, then it's going to start at natural, the whole, and the integers. If you see a negative 7, it's going to start at the integers. Okay, now rational numbers. Rational numbers are any number that can be written as a fraction. So what we have to remember is that once we get to rational numbers, that's when we get fractions and decimals. Whether that be positive or negative ones, we still get our fractions and our decimals. But we also need to remember that the way we recognize a rational number using the calculator is if we have a terminating decimal, in other words, like 0.45, it stops. Okay, that's a terminating decimal. If we have a repeating decimal, like 0.45 with a bar where it goes 0.45, 45, 45, 45, 45, there's a consistent pattern of repetition. Those are rational numbers. Now the ones that we need to focus on then after that are the irrational numbers. Now irrational numbers are numbers that cannot be written as a fraction. Okay, so these are going to be numbers like square root of 2, square root of 3, pi. So when you type these in on the calculator, it will give you the same 10 to 11 digits, but there will be no pattern of repetition. And that's how you recognize an irrational number. And then of course we have the real numbers, and we know the real numbers are two sets put together. Rational numbers and irrational numbers together. That's what real numbers are. So real numbers are any number that can be placed on a number line. Okay? Then we got three other definitions here that we have to understand and know. Okay, you have to know ascending, which is nothing but least to greatest. Descending, which is greatest to least. And then last but not least, mean absolute deviation, which is the average distance the numbers in a data set are from the mean. Okay, so we'll talk more about that one at the end. Now, on the test tomorrow, you will not have to write down a definition. You just have to be able to identify what sets a number would belong to. So the next section on the test review is a set of true-false questions. So we look at this one. It says a real number, or all real numbers, are classified as either rational or irrational. Okay, and that is true. Okay, so that one is true because we've got two types of numbers, rational and irrational, and that makes up the set of real. Okay, over to this one. Not every counting number is an integer. Well, counting numbers are 1, 2, 3, 4, 5. Are those in the set of integers as well? Yes, they are. So this statement right here is false because all counting numbers are integers. The next one. If a number is an element of the set of integers, is it also an element of the set of whole numbers? Well, it can be an integer without it being a whole number, but it can't be a whole number without it being an integer. So can it be an element of integers and also be an element of a set of whole numbers? Yes, it can be. So that is true. Okay. If a number is a set, well, actually, no, take that back. Hold on, just read it wrong there. Okay, it says, if a number is an element of the set of integers, is it also an element of the set of whole numbers? And that is false. Because if I were to give you a -5, that is a member of the integer set, but it's not a member of the whole number set. Okay? This one right here says every element of the set of whole numbers is a rational number. Every element, see that every is what is the key. Every element of the set of whole numbers is a rational number. That is true. Okay, all whole numbers are going to be rational numbers. And then the last one. The set of irrational numbers is a subset of the set of rational numbers. Now people have been asking, what is subset? Subset just means part of. So if we reread this as the set of irrational numbers is a part of the set of rational numbers, okay, that would be false. Because the set of irrational is not part of rational. They're two separate groups. Okay, now they are part of real, but they are two separate groups. Okay. Now, what number sets do these numbers belong to? Okay, so I gave you a -2. So I want to know what sets. Does it belong to the natural numbers? No. Okay, because it's got to be just pretty number, no negatives. Could it be a whole number? No, because again, it's negative. So where does it start? It starts with integers. Okay, and if it's an integer, then it's going to be a rational, and it's going to be a real. Okay, now 3/4, what you have to do is type that into the calculator, and if you do, you get 0.75. So that means you have a decimal part. So that means it starts at rational. Okay, it's not going to be one of the others. It's going to start at rational. Okay, and then it would be real. Okay, now this one, when you type it into the calculator, the square root of 2 divided by 2, you get this as a decimal. Just because you wrote it like that doesn't mean that it's automatically a fraction. Okay, so this is the decimal value. Okay, now, so it goes all the way across. So that's what I consider all the way across the calculator. Gives you all 10 digits. Okay, is there a pattern of repetition? No. So that means this number is rational and real. Now, 292, well, that one is a natural number. So if it's natural, that means it's whole. That means it's an integer. That means it's rational. And it is real. Okay, negative 19 divided by 3. So you type in 19 divided by 3, and what you get is this. Negative 6.333333333. Okay, so it's got decimal parts. Okay, so that means it's not natural, not whole, and it's not an integer. But is it rational? Yes, it is. Because remember, rationals are any repeating decimals. So this would be rational and real. Now the next one. 6.969669666. Is there a pattern of repetition, a consistent pattern of repetition? No, there's a pattern, but there's not a pattern of repetition. So this one is irrational and real. Okay, so there's your number sets. Now the next section we need to talk about is, okay, comparing and ordering. Now, this one's kind of a tough set. Okay, so what you have to do is make sure everything is a decimal first before you start looking at it. So this one is good, but 3 5/6, well, that gives me something different. So if I were to type in 3 5/6 in the calculator, I'm going to get 3.8333333. So that's 3.8. The square root of 16 is going to give me -4. 8/3, well, that's going to be 3 divided by 8. That's going to give me 2 point something. Okay, because you're going to end up with a repeating decimal in there. So that's going to be 2, and I think it's 2.6 with a bar, 66666. And then 2 times pi is going to give me something like 6.28 something. Okay, so now with that in mind, we can put these in order. Now, what order do we want? Least to greatest. Okay, so the -4.5 is going to be first. It's the smallest. The square root of negative square root of 16 is going to be next. Okay, so those are gone. And now we've got 3.8, or we've got 2.66666, or we got 6.28, so that gives me the 8/3, and then the 3 5/6, and then last but not least, the 2 pi. So what we have to do on any of these is you've got to put them into the calculator and then convert. Okay, so the rest of these I'm going to just talk about and just tell you what the answers are. Okay, but that's what you do. Type it into the calculator, find the decimal, and then compare the decimals. Okay, so on this one right here, this one, believe it or not, it says I want them in order from greatest to least. They already are. Okay, that is already greatest to least order. This one, okay, you'd have to type each of those into the calculator to get an answer. But on this one right here, the correct order, because I'm looking for ascending, is going to be negative square root of 72, negative 70 over 9, 8.25, square root of 100, and then last but not least, the 18. Okay, so that would be the order of those. And then on this last one, which one is not ordered correctly? D is not ordered correctly, because this right here, you got -4/3, which will give you -1.3 with a bar, and then the square root of 4 is actually -2. So this one should be on this side of the -4/3 instead of on the side that it is. Okay, now let's go to scientific notation. I'm only going to work a couple of these, and I'll just write the answers on them. Okay, for scientific notation, if you remember correctly, we're going to take our number here. First off, it's a big number, so that means it's going to be a positive exponent. So I'm going to write 3 times 10, because I only had one significant digit. 3 times 10. Now, the exponent is, where was it? Where did I move it to? How many places is that? 2. Okay, so the next one. Okay, there's 3 significant digits here. So 106, put the decimal such that its value is between 1 and 10. And then times 10 to the And then how many places did I move it? It was here. I moved it here. So that gives me 5 places. Okay, so this one's got a negative exponent. So this one, again, I write my 3 significant digits here. 397. I put a decimal so that its value is between 1 and 10. And then times 10 to the, and then where was it? Where did I move it? How many places in between? And there are 5, but what kind of 5 would that be? A negative 5, okay? So the next two, you should just have 4.356 times 10 to the 6th. And then the last one, 1.57 times 10 to the negative 2nd. Now, if we want to go the other direction, this is where we move our decimals. So if it's a positive exponent, I move my decimal to the right. If it's a negative exponent, I move my decimal to the left. So in this one right here, I'm going to come over here and we'll write 4, 8. And I need to move that decimal 4 places. So that's 1, 2, 3, 4. So I move it 1 place around the 8. So that means I've got to add 3 zeros. So we end up with 48,000. Okay, now this one, okay, I got to move it 9 places. So 2 places around the 7 and the 2. And then 7 more places. So 5, 7, 2, 1, 2, 3, 4, 5, 6, 7 more places. And we come back and we add our decimal, or add our commas, sorry. Now, this one, you probably would never write this one in scientific notation, but this one, I got to move it 1 place. So I move it 1 to get 37.2. Now, the last two are with negative exponents, so I have to move the decimal the other direction. So this one, I got to move it 2 places. So I write 1, 9, 2, 8, 4. And then I move it 1 place around it. So then I just add the decimal in the front. Actually, I move it 2 places, sorry. So I got to add a 0 and then move the decimal right there because I moved it 2 places. Okay, now this one, I've got to move it 13 places. Well, one of the places is right around the 3, and then I got to move it 12 more times. So that means I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times, and then the 3. Okay, so that's scientific notation. The last section that we have on the test is mean absolute deviation. So the first thing you have to do is fill in the blanks. Okay, so in this one right here, it says first, what do we do? First, you find the mean of your data. Okay, find the mean of your data. So I used one of those. Second, you find the positive difference between the mean and the data point. And then third, you find the mean of the differences. Okay, so the first thing you have to do is you've got to add up all of these numbers. And when you add up all of those numbers, if you add them up correctly, you end up with 647. Okay, now what we do with that is we take that amount and we divide by 5 because there are 5 data points. And we find out that our mean is 129.4. So we take each one of these data points and we subtract this number from it. Okay, so when you do that, you end up with a series of values. But what we want is the positive version of that. Okay, so the differences, the positive differences are going to be 17.4, 15.6, 21.4, 30.6, and then 7.4. So each of those are the positive differences between this data value and this mean. And so now what we have to do is we've got to add these numbers up. And if you add those numbers up, you get 92.4. Okay, and then we take that amount and we divide it again by the number of numbers we have, which is 5. And you find out that your mean absolute deviation is 18.48. And that's all this test is going to cover. Now, granted, your test tomorrow is not going to be fill in the blank like this for the most part. It's going to be multiple choice. Okay, so you just have to be smart enough to pick the right answers. But if you know all the information and are able to work all the questions on this test review, that test will be very easy for you. Now tomorrow, right before the test, we'll go over this again just to make sure you understand what you need to do. Okay, so make sure you study a little bit. You know, watch this video over again if you need to in order to have some refresher on it. Okay, and study the content. Okay, so until tomorrow, I'll see you later.